students, and now I'm Anil Kumar Misra going to take the second edition of my teaching to class 12. Here we will study about solution. A lot of things has been taught to you. Now we are moving further from that point. We have discussed this thing solubility. Solubility. That is what we have discussed. But in solubility, we should try to understand the concept which is given in class 11 so that you can get the clarity of the concept solubility. Now see, what is solubility? Suppose that we are dissolving this salt NaCl in water. Then what will happen? It will split into Na plus and Cl minus. Here comes a very question, I think intrinsic question, that why don't Na plus and Cl minus join together? As we know from Coulomb's law that opposite charges attract each other. Why they are not joining together? Can you make out the reason? If not, see the reason here. Na plus, you know that water is a V-shaped molecule and it is a polar molecule. Here alpha negative charge is present and over here alpha positive charge is present. So whenever an ionic salt is dissolved in water, what actually happens? You see, Na plus rotates water molecule in this orientation, keeping the negative charge point towards itself. And it develops a covering. You see, a covering is developed, and this process is called see the process. This process is called hydration of ion. Hydration of ion. And you know that there is a fundamental fact in science. And what that fundamental fact? The fundamental fact is that attraction leads to the fall in energy and repulsion leads to the rise in energy. Since water molecules are oriented in a particular design, so attraction is created over here, due to which whatso energy is liberated here is called hydration enthalpy. This is called hydration enthalpy. The energy released when the ion goes inside the water and it orients the water molecules according to its nature is called hydration enthalpy. Similarly, here this cover is developed. This is called sheath. This water sheath is present on Na plus ion. Supposedly we are taking here Cl minus ion. Then the sheath will be developed in another way. As it is minus, it will put forward the positive part of dipole molecule water. And this process is again called hydration of ion, and the energy released in the process is called hydration enthalpy. Hydration enthalpy. This is our hydration enthalpy, as a specific covering is present around Cl minus and around Na plus. This is the reason that inside the solution Na plus and Cl minus can never join together. Now, we are going to understand the things in the light of chemical equilibrium of class 11. Let us see, if you want to put here equilibrium, suppose the process has come to equilibrium. If it is on equilibrium, actually this kind of thing should not be taken into consideration. The reason is that this is a strong electrolyte. And in a strong electrolyte, the process is 100% completed. Electrolyte. So this process will be 100% completed and the process will never be reversible. If for that cause we have to take a reaction of or solubility of ion which is not completely ionic. So I am changing here the example. Suppose we want to take here BaCl2, barium chloride, which is not 100% ionic compound. So here this will give the ions Ba plus and here 2Cl minus. See the case carefully. Then here Ba plus will develop water sheath according to its nature, according to the nature of the ion, and Cl minus ion will do the same. And as they are separated by water covering in different designs, they will not join together in water. BaCl2 is not a strong electrolyte. It is treated to be weak electrolyte in comparison to sodium chloride. So it will not dissolve completely in water, and when it will not dissolve completely in water, the process will be reversible. Any reversible process comes to equilibrium point. So here we are considering equilibrium constant Kc. So Kc will be given by what? Concentration or active mass of Ba++, and here concentration of Cl minus raised to the power 2, and again concentration of BaCl2. So it is. Now we are taking this thing this side, then Kc will be, actually this process will not occur unless or until we apply water here. Medium should be required. So here concentration of medium should be taken here also. Then Kc multiplied by BaCl2, and here concentration of S2O, and here what we are getting? Ba++, and here Cl minus raised to the power 2. That is what we are getting here. Then you know that Kc is constant, and BaCl2, whatever amount you have taken is constant, and water, whatever amount you have taken is also constant. So when we multiply constant into constant, what we will get? We will get a new constant. Constant, that is new one. New constant. This new constant in this case is called Ksp. Here Ksp is equal to Ba++, and you can write here simply Cl minus. That will also do. Then Ksp, what is it? Equilibrium constant for solubility of salt. Here Ksp is equilibrium constant. Equilibrium constant for solubility of a salt. Now we are moving ahead of this concept. Now whatever derivation we have got the derivation this one, that Ksp is equal to concentration of Ba++ or here concentration of Cl minus. That is what we have got. Then this is your solubility product, and this part where ions are present, their concentration is taken. This is called ionic product. This concept is very important in chemistry, as you know that if you want to check any radical in the lab, then what happens? We check it by the formation of precipitate. So the important question is, when precipitate will form? This is the important question whose answer should be known to us. Here, when precipitate forms, when will PPT, that is called precipitate, form? So say here, precipitate will form only when solubility product is more than only when the ionic product exceeds the value of solubility product. So under this condition, precipitate will form. So this thing should be kept in the mind carefully, that when precipitate form, when the ionic product exceeds the value of solubility product, under this condition precipitates are formed. Now if we want to calculate the solubility of a salt, then how can we do it? See the formula. Suppose that here the solubility is S and this will also be S. According to the number of charges we take the value of S. Say here. So KSP, suppose the solubility of this salt is S, then here it will be 2S into S because it is divalent ion. Divalent ion. And what is this? This is monovalent ion. For your convenience, I am writing here the ion itself Ba++ and here it is Cl-. For monovalent ion, we take only S. What is this? S is solubility. S is solubility of a salt. Solubility of a salt. If you want to calculate the solubility of the salt, then it looks very clear that 2S square will be KSP. Then S will be KSP divided by 2 root under. By this formula, we can calculate the solubility of any salt. Okay guys, now we are moving ahead with the topic whatever is present in the syllabus of class 12. We have discussed the solubility of solid in liquid. In that part, you have seen that there are three kinds of solutions. One is called saturated, another is unsaturated, and third one is supersaturated solution. Here we are going to consider solubility of a gas in liquid. Solubility of a gas in liquid. As for biology, you better know that without oxygen, no one can survive in the world. Whatever plants and animals which are present underwater, or aquatic animals and plants, they are living inside water because oxygen is present inside the water. So, it gives us indication that gases are dissolved in water also. So how can we increase the amount of oxygen in water or any other gas inside the water? That we will see today. So solubility of a gas in water or in liquid. Here one scientist, after carrying out a lot of experiments, gave his law that we call Henry's law. Henry's law. And what is the statement of Henry's law? Henry says that the solubility of a gas in any liquid is directly proportional to the partial pressure of the gas over the surface of the liquid. See here, the statement. The solubility of any gas, the solubility of a gas, solubility of a gas is directly proportional to the partial pressure of the gas, partial pressure of the gas over the surface of the liquid, over the surface of the liquid. Now say, this is the statement of Henry. Henry's statement is what? The solubility of a gas is directly proportional to the partial pressure of the liquid gas over the surface of the liquid. Now recall your chapter, Dalton's law of partial pressure. If we will go to the final point of Dalton's law of partial pressure, we will get the value of partial pressure by what way? From Dalton's law. From Dalton's law of partial pressure. Law of partial pressure. Say the pressure of any gas is P, then it will be calculated by what way? P into X dash. Here P is the partial pressure of the gas and P is the total pressure of all the gases. Total pressure created by all the gases. Total pressure. And what is X dash here? X dash is the mole fraction of the gas. Mole fraction of the gas. With the help of this formula, we can calculate the partial pressure of any gas over the surface of the liquid. As per Henry's law, if we want to discuss Henry's law, the formula derived by application of Henry's law, then the formula is as per Henry's law. As per Henry's law. As per Henry's law, you know that P is equal to KH into X. Here I am writing X. X is what? X is gram per liter. That is the value of X. How much gas is dissolved inside the water? That is given by X. And the value of X is read in gram per liter. So here P is equal to KH into X. It means that we can calculate the partial pressure or the amount of gas dissolved inside the liquid with the help of this formula. What is KH? Now see, KH is proportionality constant. KH is proportionality constant. Proportionality constant. KH is here proportionality constant. Now we will try to understand the things ahead. Let's see the formula. P is equal to KH into X. Okay. Now see, what is X? X is the gas, solubility of a gas, and P is partial pressure. KH is Henry's constant. Why is Henry constant taken here? What is the need to take proportionality constant? We should try to understand this thing. So KH, the value of KH depends upon the nature of gas, on the nature of gas or and on the nature of liquid, and this is always constant. If we are carrying out an experiment over a certain gas or inside a certain liquid, then KH will remain constant. When you will change the gas, the value of KH will be new. When you will change the liquid, the value of KH will be again new. Now let us try to understand how Henry came to this conclusion. Henry came to the conclusion by carrying out an experiment. See, this is the experiment. He collected a data by what way? See here. Here gram per liter solubility and here partial pressure. Supposedly, I am just taking the reading here A1, this can be B1, and here A2, this can to be B2, and here A3, this can to be B3. In that way, he prepared a reading table, and on this reading table, he plotted a graph. See, this is the graph. When he plotted the graph, then the graph came to be in this way. On x-axis, supposedly, he took solubility, and on this axis y, he took what? Partial pressure. Then this was the graph. And you know mathematically, what is that? The equation for straight line. Equation for straight line. Equation for straight line is what? That is known to you. You must have studied this thing in class 10. Y equals to mx plus c. That is known to you. Supposing c may be any value, it is called intercept. Intercept, and this one m is tangential coefficient. Tangential coefficient. This is tangential coefficient. So both are constant, you know. As both are constant, taking out constant, what we are going to get? Taking out constant. When we take out the constant, then what we are going to get? Y is proportional to x. That is how Henry found out his law, or he established his law. So solubility here P is equal to KH into x. This is how Henry came to the reading. This is of Henry's law. Now application of Henry's law is quite wide in normal, I think in factories or in normal observation. I am just going to discuss some of the things where Henry's law find large application. Number one, Scuba divers. Scuba divers. Now, what is the meaning of scuba? Scuba diver means deep sea divers. Deep sea divers. Deep sea divers. When divers go deep inside the sea, under that condition they carry with them oxygen. Along with oxygen, certain inert gases were kept inside. Supposedly, initially nitrogen gas was kept inside. Oxygen and nitrogen, this was the mixture that was filled in the gas chamber and they died inside. When they came out, what happened? They died soon, vomiting blood. What actually might have happened? That we have to understand. The size of nitrogen is quite big. Size of nitrogen is quite big. And when the pressure was very high inside the liquid, then what happened? This nitrogen entered into the blood. This nitrogen entered into the blood, and from blood it has gone to interstitial tissue. But when they come on the surface, when they started coming on the surface, the pressure was dropping badly, and due to the drop in the pressure, this nitrogen started coming out from the blood, and ultimately this resulted in vomiting and total collapse of the body. So the scientists started thinking on the line of Henry, and they said that if the gas which is filled, inert gas which is filled, if its size is small, the work can be taken. And again, what they decided? They kept inside helium. Helium gas was taken. So this was the idea which they took over Henry's law. Now we are going to discuss the second application of Henry's law. The second application of Henry's law is in the cold drinks. Cold drinks. The companies which prepare cold drinks, you know that cold drinks is also called carbonated drinks. Carbonated drinks. And this carbonated drinks, it is called carbonated drinks because carbon dioxide is dissolved. Carbon dioxide is dissolved in the liquid. In the liquid, you know that the dissolution of carbon dioxide will take place highly only when the pressure is very high. So what happens? This carbon dioxide is dissolved at a high pressure. Is dissolved at a high pressure. At a high pressure. At a high pressure. And you see, this pressure is maintained in cold drink by what way? You have seen this thing. In cold drink, this pressure is maintained by applying a cap over it. When you will remove the cap, you will notice what is happening there. Certain bubbles start coming in the upward direction. These bubbles are nothing but they are molecules of carbon dioxide. They are going up because the pressure is released from here. When pressure will release, carbon dioxide, the solubility of carbon dioxide will decrease. Subsequently, carbon dioxide will escape out of the liquid, which happens here. Now see, the third case which we are going to discuss, that is the application of Henry's law. What is the third case? Second. In winter season, see, in winter season, fishes are quite happy inside the ponds and water bodies. Winter season they are happy, but in summer season they are in trouble. In summer season, but in summer season they are in trouble. Let us try to understand the concept. In winter season, you know that air is loaded. Winter seasons, the sun is very low, you know, due to low sun, less heat comes, and water molecules are also present in the air, due to which the partial pressure over the surface is very high. Due to high partial pressure, what happens? Oxygen dissolves inside the water body in adequate quantity. Adequate quantity. Adequate quantity. But when the sun is very high, suppose here the sun is very high, then heat is very high. Heat is very high. When heat is very high, all the molecules, gaseous molecules, tries to go in the upward direction. When they go in the upward direction, due to which the pressure over the surface of liquid is low. Due to low pressure of air, low pressure. What happens? The molecules of oxygen which are in dissolved case inside the water is less in quantity. Is less in quantity. Thank you guys. Hello.